All right, we're wrapping things up and we want to kind of circle back to do some work in equations and expressions, and that way you will be totally set when you start algebra in the fall. Okay, so you have this packet, and I want you to first make sure you get your name up there because there isn't exactly much room for your name, so go ahead and get that up there. All right, then turn it over to this first page, and I'll stop and pause you for a minute and say, do you remember when earlier we talked about the distributive property? So something like this. I call it old people math because let's say that I am going to buy 7 items and they are $2.98 each. Okay. And I'm not going to use a calculator because in the old days, we didn't have them handy like you do have them all built in on your phone now. So I can do something like this. Say, $2.98 is the same as $3 minus 2 cents. Agreed? Yep, that makes sense. Now the distributive property says I can do this. I can take this 7 times just the $3 and then take 7 times this 2 cents. I'm going to put that subtraction sign right here. 7 times the 2 cents. Oh my goodness. This is a lot easier to be able to do in my head. $21 minus, multiply these to 14 cents, which means if you can do this in your head, $21 take away 14 cents. Well, that means take away 10 cents. So I'd have 90 and 4 more means 86. Boom. There you go. So distributive property is helpful when we start simplifying some expressions and solving equations in algebra. So I need you to turn to this part here. And all we're going to do here is just jump into practicing distributive property here. Okay, so here's what this problem says here. 6 times 11 plus 8 means 6 times the 11 and 6 times 8. Yep. 7 times 14 plus 12 means you take 7 times 14 plus the 7 times the 12, and so on. Okay, getting that? All right, jump to the next page. We're just going to kind of blast through here and make sure you remember some things about this. All right, term. A term is something that's in some sort of expression, and here's what I'm going to say. Terms are separated by addition or subtraction signs. And here's what I mean. Something like 7x plus 5y minus 14z plus 12. Okay? Each of these things is a term. Okay? Each of those is a term. So that's what I mean. If we have like terms, that means that they are terms that have the exact same variable and the same exponent on the variable. So I'm just going to write it as same power. Okay? So if I have something like 5x and 14x, they have the same variable, same power. If I had something like -2 and 15, neither of those have a variable. They're plain numbers called constants, and you can combine those together. Okay, let's do one more over here. I know I write big. 10y squared and 4y squared. They have the same letter and the same power of that variable. Okay, so we watch for that. Anytime you see terms that are alike, you can combine them together. Okay, an equivalent expression, let's say I had something like this: 3x plus 7x That's an algebraic expression. But if I combined them together and got 10x, these two are the same thing, okay? What I did is I simplified it to combine things together. So simplifying usually means make, well, I won't say make. We usually just say combine like terms and make that expression more compact, more succinct. Combine like terms. So if I had something like, 8x plus 5y minus 4x, blah. Take the terms that have the same variable with the same power, 8x, and this 4x. And remember, I always talked about you got to take that sign that's right in front of here. So this 4x, I want you to think like negative 4x. And we simplify by saying, well, I can rearrange this by using the commutative property and say the 8x and the 4x, those are like terms. They can go together. The plus 5y doesn't have any other y terms, so I combine those together to look like this. A 4x plus 5y, and now you're done. That's all you can do. All right, so let's look at a few examples. 14a minus 5a. Look for the like terms, okay? Combine the coefficients. What is that word? The coefficient means what is the number that is in front of the variable that's multiplying the variable together. 14 minus 5 is 9. That's what you're thinking in your head. So you have 9a. Excuse me. Look at example 2. Identify these like terms. Let's see. I have a 9x and I have a minus 2x. The 9 minus 2 gives me a 7. So I have 7 x's. That takes care of that and the minus 2. I still have a plus 3y. That can't be combined. And the number 5, that's called a constant. That doesn't have any other plain old constants. So that's as much as you can combine. Now, when we start thinking about distributive property and simplifying, here's what we have to do. Take 6 times the 5. They show you that right there. So that's 30. We have to take 6 times the n, and really there's a 1 in front of that n, so it's just going to be a 6n when you combine that one. And then we still have this subtracting the 2n. Because 6n and 2n are like terms, that means I can take 6 minus 2 to get 4. So I'm going to have 4 n's. See that n there? The 30 is a constant. It has no variable. That's as much as you can do. Okay? That's as much as you can do. So now, when we went into equation solving, if you see that you can combine like terms first, that's what we're going to do. Keep in mind, if you just have a variable, that has a coefficient of 1. 1x plus 3x equals 4x, because we're identifying the like terms. The coefficient of this guy was 1. 1 plus 3 is 4. Now, you always want to find the variable, get it on one side of the equation, and get it alone. Because 4x means 4 times x, we're going to undo that multiplying with divide. Divide by 4, divide by 4. 4 divided by 4 is 1, so I have a 1x. My answer is 12. There you go. Let's look at a couple of these. Can you combine this whole mess into something far more compact, succinct? Go ahead, pause the video, do these two, and let's see how you did. I have a 5c. Remember, keep the sign with the term that comes right after it. A minus 4c. Here's another one. A minus, and I'm going to write the one in there. 5c minus 4c. That gives me a 1c. 1c minus another 1c. Big fat old 0c. 0 times anything is 0, so all your c's got wiped out. I'm left with a positive 8 and a minus 2 or a negative 2, 6. All of that mess is just equal to 6. Crazy! Look at these guys. We have a 9D, and you'll notice I'm kind of rewriting things to the side so I don't get confused. And then keep the sign right in front of it, minus 4D. So that part, those two combine to give me a positive 5D. Now let's take a look at what's left. I have a positive 7Z. I'm going to put that sign right in front of there so I'm keeping track of what sign my numbers are. And a minus 2C. That gives you a positive plus 5C. Ta-da! All right, here's your assignment. Do this page for tomorrow in your packet. Show some work, combine like terms on these first 15. You are just simplifying the expression, so you're not going to be able to determine the value of the variable. Once you get down to these last few with the equations, your final answer should be able to tell me what the variable equals. What does B equal? What does Y equal? Good luck. May the force be with you.